Question number 4 is on the blood grouping system. So according to the questions, if let's say the individual is having the genotype, right, homozygous M, then it will be having group M. And then if let's say it is homozygous N, then it will have the group N. But if let's say it is heterozygous M and N, then it will be group MN. Okay, so I think based on this, we can easily see that this is actually a co-dominant. Yeah, it's actually a co-dominant because when both of the gene are there, when it's a heterozygous, both of the gene will be expressed. All right, so it's like a AB blood group. Yeah, when you have an A blood group and B blood, A blood allo and also the B blood allo, you will be AB blood group. So it's the same concept, right? It's the same concept. So based on this, well, now we know that this question is related to what? It's related to the deviation. Okay, and it's related to the codominant. All right, and based on the questions here, A is just asking us to name the type of inheritance. Okay, so yeah, that we don't have to use any type of the method. But for B, you can see that it is asking for frequency of the allo. It's asking for frequency of the allo. So if it's asking for frequency of allo, then we have to use type 3 method to solve the question. So type 3 will means that either we use the normal way, right, to solve, or we can use the formula, yeah, the formula way, the p squared plus 2pq plus q squared equals to 1, or the p plus q equals to 1 formula to solve this. Okay, so now we look at question A first. So question A is just asking for the type of inheritance. So this one we have mentioned it just now. So this one is actually the codominant. Okay, so this would be the type of inheritance. Then next B is asking for the frequency of the allo. Yes, frequency of the LN allo. Yeah. Okay, so for this one, if you look at the questions, there are numbers. M blood group number is given. The number of individual has been given. Okay, then MN blood group is also given already. N blood group is also given also. So that means that this is a question that gives us enough data. Yeah, that gives us enough data. So that's why we can actually use a simple way to solve it. Right, directly we count the number, yeah, the number way. Okay, so what we can do here is, since all the number of individual is given, so we will list them down first. So those individual with homozygous M allo, total number is 1787. Yeah, 1787. Okay, so those that is heterozygous, total number is 3089. And then those with the homozygous N, that total number is 1303. Okay, so since the question is asking for frequency of allo, so we have to count the number of allo lah. Yeah, so it's Ln, yeah, the N allo, yeah. So N allo, we have to look at it one by one. So for the individual with LM, right? So they have no Ln allo. They are M, not the N, yeah. So that's why they don't have any Ln allo. So we can times 0. So for those that's heterozygous, you can see that every individual got 1. Yeah, they got 1 Ln allo. So that's why this is the total number. Everyone got 1, yeah. So that's why we will times 1. And then lastly, the homozygous N individual. So this individual got 1 copy, 2 copy. They got 2 copy. So that's why every individual got 2 copies. So you times that. This one, of course, it will be 0. So this one will have 3089. This one is 0. Okay, so then this one will be 26, yeah, 0, 6. Okay, so total, yes, that is the total number of the L and L. Okay, so we have to sum it up. It's the calculator. Okay, so 3089 plus 2606. So we will have 5695. Yeah, 5695. This is the total number of the L and L. Yeah, L and L. So you want to know the frequency. So frequency of the L and L, it will be, okay, so you will take the total number of the L and L, 5695. So you have to divide with the total number of the L. Yeah, total number of the L. Okay, so to know the total number of the L, then you have to sum up the total number of the individual here. Yeah, total number of individual. Yeah, so we will plus all of them. Yeah, sum up all of them. Yeah, 1787 plus 3089 plus 1303. So total is 6179. Yeah, 6179 individual. So every individual have two error, right? So that's why 6179 you have to times 2. So total number of the error would be 1, 2, I'm sorry, 1, 2, 3, 5, 8. Okay, so that's the total gene pool. Yeah, we can say that as gene pool as well. Okay, so with that, yes, you will take 5695 divided by the answer. Okay, so that would be 0.46. So that's how we get the this question done. Yeah, using the normal way. Yeah, using the normal way, because for this question they are giving us all the number of the individual, so that's why we can do so. Okay, so if let's say we want to use the formula way, yeah, if let's say we want to use the formula way, yeah, let's say there's another way. So I will just show you also. If let's say I want to use the second way, which is formula way, so basically this is slightly different because it is codominant. So codominant means that you don't really see the recessive trait. Yeah, you don't really see the recessive trait. Yeah, so that's why there should have some changes, some amendment. Okay, so this is what we will do for those M blood group. So that means the LMLM, yeah? For the M blood group, we will consider them as the P square. For those MN blood group, MN blood group individual, the frequency, we will consider them as the 2PQ because they are the heterozygous. Yeah, they are the heterozygous, yeah? Because M blood group is L, M, L, M, right? So we will consider them as the P square. While this MN blood group is LMLN. They are heterozygous, so that's why we'll consider them as the 2PQ. While the N blood group, okay, we will consider them as the Q square. So over here, the Q square, yeah, supposedly in original formula, Q square should be the homozygous recessive individual, the frequency for that, yeah, homozygous recessive individual. Okay, but since over here we don't have really the recessive one because it's a codominant, so we will assume that the ln is the Q square. Okay, so by doing this, so Q square will be equals to the number of the N blood group is 1303. Yeah, 1303. Yeah. So that's why it is 1303. That's a number of individual with the homozygous LN. So you have to divide with the total number, yeah, the total number of the individual here. So like what we calculate just now, total number of the individual is 6179. Yeah, it's 6179. Okay, like what we calculate just now, yeah. So that's individual, yeah, the total number of individual. So with that, yeah, we can start the calculation. So Q square would be equals to 1303 divided by 6179. 0.279. Okay, so it would be what? It would be 0.2, yeah, 0.21. Okay, so we will do the solve the equation. Q equals to the square root of 0.21, and thus Q equals to square root of the 0.21. Yeah, so that would be 0.46. Yeah, so it's the same answer. Okay, it's 0.459, right? So we make it to become 2 decimal point only, which is 0.46. So yeah, different way, but still you will get the same answer. Okay, so both of these way they are considered under the type 3 method, yeah, under the type 3 method, where you use the formula or you don't use the formula. Okay, it depends on the questions. That depends whether the questions give you the all the data or not. If the question give you all the data, then normally we will prefer to use this way, the simple way, which is straightforward, right? But if let's say the question didn't give you much data, then yeah, this is the formula way that you can use to solve. Okay, so with that, yeah, that's all for the question number 4.